Math is the best. Math is life. Mr. Ang, the best teacher in the West.
Two-way table shows the classification of students in a mathematics class by gender and dominant hand. A student who is ambidextrous uses both hands equally well, which means you can use both left and right. Actually, I think my layups for basketball is better in my left hand, and I shoot better with my right hand from far. Part A, what is the probability that a randomly selected student in the class is female? Okay, given, keyword guys, given that the student is right-handed. So we would write this as probability of female given that they are right-handed. What does this mean? The right-handed, you're going to look at how many people are right-handed. That's the denominator. And so that would be this one right there. 23 people are right-handed. Okay, looking at just the right-handed people now, how many of those are female? Female would be 12. So I have 12 out of 23, which would be choice C. That one's a conditional probability problem. This problem is just match each term in this definition and each formula to its own. So I'm going to write over here, I'm just going to use numbers 1, 2, 3, 4, and I'm going to call these A, B, C, and D. Okay, which one, probability of A or B of if events are not mutually exclusive. Not mutually exclusive. This is kind of like the boys, blonde, and then subtracting those that are both boy and blonde. That would actually be B. This formula down here. Okay, what is a complement? Remember, that's the yes plus no equals 1, and then you might have something like the no's are equal to 1 minus the probability of yeses. Okay, so what do we got here? Well, this is the only one that has the word complement. Given a set A, the complement of A denotes A prime is the set of elements that are not of A. So this notation here is A and not A equals 1. That's what it's trying to say there. So the answer for that one would be 2D. This one down here. Okay, number 3, mutually exclusive events. Two events that cannot occur simultaneously, meaning that the probability of the intersection of the two events is 0, also known as disjointed event. Yep, that's that one. Because remember we talked about in class that the intersection, there is no intersection. Then that would be that one. So that would be 3C. 3 is C. And then number 4, conditional probability. Remember, conditional probability, you have this condition. Given B, so that was in the denominator, and then their intersection of both A and B. So this one is A. Okay. Number 7. Felipe surveyed students at his school. He found that 78 students own a cell phone and 57 of those students own an MP3 player. MP3 player is like an iPod or something that plays music. There are 13 students that do not own a cell phone but own a MP3 player. 9 students do not own either a device. A two-way table for the information is given below. Okay, so in this problem, just take your calculator and just do a bunch of subtractions. So to figure out A, I'm just going to subtract 78 minus 57, and that gives me 21, right? 57 plus 21 gives me 78. 13 plus 19 gives me 22. Going down, 21 plus 9 gives me 30. And if you add that, you would see equals 70. And 70 plus 30 gives you 100. And 78 plus 22 gives me 100. So A is 21, B is 22, C is 70, D is 30, and E is 100. So that's just filling out a two-way table. All right, Venn diagrams. Teachers at Green High School have asked students which social media site they prefer. Students in 2 classes have been surveyed. The following questions has 3 parts. First, answer part A, and then second answer part B, and then answer part C. So there's 3 parts. Mr. Smith asked his class if they used either social media A, social media B, or neither, and he compiled the results in a Venn diagram. Okay. So, part A. Use the diagram to select the answers to complete these sentences. Okay. So you have multiple choice for the second parts. I think you had a drop down. Let's see. No, you were just asked to find the number of students. Number of students here. Okay, so if you just have A, remember this one, union, or A or B. So A has how many? A has 20. So probability of A is 20. The probability of B you have 18 here, so that's the whole circle, right? So it's 12 plus 6. And then, of course, you would subtract their intersection in there. So, because you're double counting those 12 students. So that would give you 38 minus 12 would give you 26 as your answer. Okay, these are students that are what? Use either A or B or both. Double check that one. Yeah, remember we want the either. This one does not have the word and, nor is like a complement and starts saying no, not A, not B. We want the keyword or. So that would be that choice. You can have the word either in there, but that's the selection. You pick a card at random from the following cards. Put it back and then pick another card at random. So how many cards are you picking? We're picking here 2 cards. 2 cards. And it kind of tells you this is the first card and this is the second card. Well, if I want to summarize, there are 5 of these, and the probability of getting, say, red would be, how many red cards are there? 2 out of total 5. And then yellow would be 2 out of 5, and the probability of blue would be what? 1 out of 5. And remember, if you add all those up, the probability should equal 5 over 5, which is 1. Remember, probability can only be 1. Okay, so here's another question we have to answer. From the first to the second card, are the events independent? Is the second choice affected by the first choice? And the answer is, it doesn't affect it, so you are independent, yes. Okay, why is that the case? You pick a card at random from the following cards and then you put it back. There's the key word, put it back. Because if you, they say don't replace it, or let's just say you eat the card, that means there would only be 4 cards to choose from on the second choice, not 5. And then that way, that would not be independent. The second choice would be dependent on the first one, because you have 1 less card. All right, so the probability of, whoops, that's a highlighter. So probability of blue, and because they're independent, I can now multiply a probability of blue again. And that's just right here, that's 1/5, so 1/5 times 1/5, multiply across, you're gonna get 1/25 is your answer. Now it says write in a fractional form. I hope I don't see any decimals. That's the answer for number 1. Two events, A and B, are independent. Keyword there. Probability of A is 0.3. And probability of A times B is 0.24. What's the probability of B? So remember, when the events are independent, and I see the word and, what does that turn into? Multiplication. Here, these are all puzzle pieces, so we wrote this one down. Okay, let's interpret this one. That one turns into multiplication. The probability of A times the probability of B equals 0.24. Now let's use this puzzle piece. Probability of A is 0.3. Every time I see probability of A, I can write 0.3. And here you're just solving. So this problem is just a test if you knew that the word and independent means multiplication. So if I divide both sides by 0.3, this cancels. You're left with probability of B equals, put that in your calculator, you get 0.8. 0.8 is the correct answer.
Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.